Okay. So yesterday I'll just touch on some topic, and today I'm just this arumugam actually I've connected, and just for a few minutes in the initial, we'll just go through the HDFS once again and just check whether how like is there any doubts or are we clear in the topic. Just we'll go through the concepts once. After that we'll go into the questions yesterday what we had, and today Usmanji will cover the remaining part on high availability and those things. Okay. So basically, so I hope and I checked with everyone. Everybody is clear with HDFS concepts, right? So let me just ask few questions, and let's see if we can come to the point where actual things are going. So block size of the HDFS. Yeah, sure. So we know HDFS is a file system. HDFS is a file system in Hadoop, right? So HDFS stores the data and distributes everything is fine. Yesterday we saw how it distributes, how the block is working, and everything Usman already covered. And the block size of HDFS is, so anybody know what is the block size of the HDFS? Anyone can answer? It's just kind of starting questions. So anyone can answer. Yeah.
Okay. In the
5,000.
in version 1, 16 GB.
64?
64
in version 1, version 2, 128 or 512.
128 or 512.
512.
Okay, what is the minimum one in version 2?
We'll go with 128.
128, right? So maximum up to we can go to 512, right?
Yeah.
Okay, that's right. And anybody know what is the block size in NTFS, which is the file system in your laptop? What is the block size of NTFS file system? Yeah,
128 KB.
128 KB. 128 KB,
Yeah.
or it is bytes?
KB.
Okay. Are you sure?
No, you guess.
Okay.
So I heard is 128 yesterday. Maybe it could be a byte also.
Yeah. So okay, it might be 120 KB or 120 like 512 bytes usually. Okay. Either the usually 512 bytes is the block in NDFS, and
Okay.
if 512 bytes is block size for NTFS, if you compare it with the HDFS block size, that is 64 MB is minimum, and version 2 it is 128 MB is a minimum block size of HDFS. So why do we have this big block size compared to NTFS? Why do we have large block size in HDFS?
Why do we have a large blocks in HDFS? Because we are operating in a distributed mode.
Okay.
And also we maintain copies in each node.
Okay, distributed.
Distributed, so
we will be maintaining large files, not
large files. Okay.
The volume of data is high.
Volume of data is high. Okay, good. That's also one of the reason. Okay. So yeah.
network, because of the network, because NTFS will not operate in a huge network, right? So here we have a network.
Okay, but how if it's a network, it has to be less, right? If it's a network, then the network congestion will be more, right? Why do you have to go for large?
Okay, then as Sivaram said, with the high volume and with the more networks to handle the process of the data, we need
high volume and more network. Okay, so yeah, okay, almost it's kind of near. Network is not a problem. That is fine. And okay.
Parallel operating.
Parallelly operating. Okay. Parallelly operating is right, but it is not why the block size. What is the benefit we'll get if it is a parallelly operating and the block size is big?
The thing is, it has to process and then give the results to the base, right? For the most.
Okay. 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 We'll go to more basics. Like, what is block? What is a block? What is block? We'll just remove all the sizes and all. That's fine. What is a block actually?
Container to store the data.
Sorry, container.
Container to store a data.
Container to store the data. Okay. So in other words, what we can say is block is a minimum space. Like you are
Minimum, yes.
storing the data into the like we just copy and paste it to somewhere in our files. But under the need, it will be storing into the minimum chunks of data. So the minimum chunk a file system can store is a block. Minimum chunk a file system can store is a block. Okay. In our laptop, whatever we are using, NTFS and those things, the block size is very less, like 512 bytes only. If you just copy 1000 MB files, 1000 MB, sorry, 100 MB file or whatever file it may be, you just copy into your D drive, E drive or whatever drive. Inside, in the behind hoods, in hard disk, it will be split into 512 bytes. So this divided by 512 bytes, that much blocks it will occupy. Okay, that is called blocks. And okay, now everybody clear what is block, right? The same thing in HDFS, we have it very large block is 64 MB or 128 MB. And why it is so? Let's say in our laptop, it's just I'm comparing our laptop and those things. Laptop we have 1 TB of data, and we wanted to transfer. We wanted to transfer it to another laptop. Like copy all the data to another laptop. How long it will take? For example, 1 TB data we just need to transfer to another laptop. We have all the files and all the web series, everything we have. We're just trying to copy into another system. How long it will take?
It may take several hours.
Exactly. It will take minimum 4 to 5 hours. Okay, 4 to 5 hours of time just to copy 1 terabyte of data. Okay, it is not more. It is just 1 terabyte of data, just copying. We are not doing any processing, nothing. Just copying the file from one place to another place. Okay, so, but in big data world or whatever we are going to deal with, that is having huge data in production wise. So it might grow up to 5 terabyte, 10 terabyte. I've seen personally 5 terabyte file, 10 terabyte file itself. And you might have also seen large files if you are working in data warehousing platform. So in those cases, if it takes to just to transfer the file is take this much time, we need to think of something else. So that is why HDFS is mainly used for. It is used for very large files. Hence there is a different design required. Okay, so one main thing is, so if let's say the files are copied in a disk, hard disk, even whatever it is, it will be stored in some disk only. So if you want to transfer some file, if you wanted to transfer some file, and then what will happen is the total transfer time it takes to transfer. Sorry, before that there will be a head will be there. Okay, there will be head will be there. This is a head, reading head. Okay, this is what the hard disk, this is a reading head, and total time to transfer the data is equal to head movement to the starting of the block plus total transfer time. Okay, so let's say we have a 100 MB file in our local HDFS, local NTFS, your laptop, and it has to go into each block to start, and then it has to read 512 bytes, and then it has to copy into the another location. So if we have lot of blocks in our file system, it will take up lot of the time. The head movement will take lot of the time. But in HDFS or Hadoop, we are going to deal with large files. We will be dealing with large files. So the block size can be more, because once I start to any file block starting, I can at least go up to 64 MB. In version 2, 128 MB I can go up to. With that, I don't have to. I can reduce the movement of my like this hard disk head, like head movement. So that will take me save me a lot of time. That is why the block size is larger in HDFS. Okay, the file size is a very it's a very least amount of like files we can store, but that's why the block size is larger in HDFS, because we are going to deal with large number of data, so that we can easily stream the data. Once it starts, it will go up to like it will continuously go to the data till the end of the block. Is that clear? Why the block size is big in HDFS?
It's clear.
Yeah, the configuration that we are keeping in our HDFS, correct? Same way, we can also increase the NFS configuration.
Exactly. If you increase it into NTFS, I'm not sure you will not be able to increase it to 54 MB or something. It will never allow that much big, because it is working in a different way, and it will be max will be up to some max. I believe it will be in KBs only. It cannot grow beyond MB. I'm not sure, but that's my just assumption, because that works in a different way. And if 512 bytes is there, right? There is one more comparison we need to do here. Okay. Here 512 MB, here 512 bytes. Okay, bytes and then KB, and then it comes like bytes and then kilobytes and then megabytes. Okay, it comes like 512. We need to add 1032 1032. We need to multiply these things. In this case, if let's say you are storing 612 bytes in your NTFS, what happens is one block worth of 512 bytes is occupied. Okay. And what is the remaining? 512 divided by remaining 100 bytes are remaining. 100 bytes remaining. That will be occupied by another 512 bytes. And if 512 bytes is occupied, there will be 412 bytes is left out, right? 412 bytes is left out. There is no data be stored in that 412 bytes, correct? Everybody is getting the point? Like I want to store 612 bytes of some file. Store in my NEFT, I put NEFT, sorry, NTFS. Okay, 512 bytes is occupied first, and then 100 bytes is remaining. Another 512 bytes of block will take up the 100 bytes. Fine. So remaining 412 bytes in the second block, right? So you can answer in the chat box also. Still now everybody is clear?
It will be unused, right?
Exactly. It will be unused in NTFS. This will be unused. This will go unused only. No other files can be stored in this 412 bytes. It will be unused. But if we take the HDFS, same scenario. We'll take HDFS. The bytes, instead of bytes, we'll have MB. Okay, because it's a megabytes, we'll go with MB. Take up 100 MB. Remaining bytes, remaining 412 MB in the second block. This will be reused by the next block. This will be reused for next block, and it will be the next block will start from that block point itself. So that is a difference. Okay. About Anandji and Anbuji.
Yeah.
Ganeshji. Got it?
Yep.
Yeah, we got it.
So Shankarji and Sivaramji and Wilsonji. Everybody is clear till now? Why we are saying these things very in a level, I'll just tell you in a few minutes. Like this is a hardcore of HDFS and MapReduce, everything whatever we are saying. So that's why. One thing is why the block size is bigger in HDFS. That's what we just answered. So anybody is not clear or anybody needs some any queries, you can just ask. I'll just pause for a minute. You can ask doubts in chat window also. I just ping. If you're okay, you can just say okay. We'll just go ahead.
What context are we going to discuss with this block size more?
Exactly. So the context here is each file system serves a different kind of purpose. Each file system serves different kind of purpose. Okay. So HDFS's purpose is to handle large size of files. So that is why it is designed. So based on that only, every detail is designed in HDFS. We cannot have HDFS file system for everything, because why? It is designed for certain number, certain level of files and certain amount of problems only. If the file is large, yes, we can go into HDFS. If you have a lot of small files and all, you cannot go into HDFS. That's why it is designed. It is designed to solve a particular problem. That's what I'm trying to make a point here. So if you see, HDFS distributed file system is a distributed file system designed to run on commodity hardware. That is the first point. And highly fault tolerant, designed to deploy on low cost server. Okay, that is fine. Okay. Hardware failures, streaming access, large. Okay. Okay, the context is the purpose of the handle is a large size of files. That is why we have everything that is in place. And also in the first point we mentioned, the Hadoop distributed file system is a Hadoop HDFS is a distributed file system designed to run on commodity hardware. So this is also, so currently what we are seeing is we are just trying to see HDFS in an overall picture and in a use case perspective initially, so that we understand why we need HDFS first of all. Okay. Designed to run on commodity hardware. So what is commodity hardware?
Cheaper.
Commodity hardware. Okay, yes, exactly. It is cheaper hardware. Okay. And anyone working in Teradata or Ab initio or some kind of high-end system, Oracle or SQL Server? So, sorry, that's okay. So why can't we use Oracle in commodity hardware, and why can only Hadoop?
One thing is a licensed product and it's quite expensive.
Okay. Licensed product. Okay, but anyway, this will.
It's an RDBMS.
RDBMS. Okay. RDBMS. Okay. So, any other answer or anyone like to make a point? Guess. You can just guess. There is no right or wrong. You just. Okay. So.
Because Oracle is not a file system.
Oracle is not a file system. Yeah, that is correct. Oracle is a file system. And if you think it's not just Oracle, any other, why can't we use? I just give an example for Oracle. You can get any file system, something like Ab initio, anything. Why can't we use other expensive softwares? Softwares in a commodity hardware. Why do they require specific productions or something?
Because one of the factor is the cost, right? We have to limit the cost of the.
No. If we use the expensive software, the cost will be higher, right?
Yes.
So they can come to the lower one, right? Even those Oracle and Ab initio and those. I'm just taking Oracle as an example, but it is not just only Oracle. All the other systems, even Ab initio, there is a thing called Ab initio. It's a ETL tool, something like that. All the tools, which even SQL Server requires high-end software, hardware, the cost will be higher. If they can use the commodity hardware, the cost will be lower, right? But why they cannot use commodity hardware? If Oracle use commodity hardware, the price will be much cheaper. If Teradata uses commodity hardware, the price will be much cheaper. But why can't they use?
Because they expect us to use higher end hardware systems.
Yeah, exactly. That is a point. But why they are expecting us to use the high end? Is there any other technical problem related to this?
Because they need to have a very
High availability, right?
high availability.
Exactly. We need a high availability. But does that mean Hadoop or HDFS is not?
Hadoop is also having high availability, right?
Yeah, exactly. So why they require expensive hardware to provide high availability? In that case, Hadoop is able to provide the same with the low level hardware. That is a question we will be answering right now. And yeah, what is the drawback with commodity hardware is it will break. It will break easily. The amount of failure is very possible. It's very possible. It can break almost one in a day. Like let's say you have around 4,000 nodes. The chances, the probability of failing is one node per day. That's what they estimate.
So one question, you said definition of commodity hardware is only a cheaper system?
Exactly. Definition of commodity, what is commodity hardware is, it is bit cheaper. Means its quality is little bit less. And you can compare to is hard disk. Like you have memory card, right? There is class 1, class 2, class 3, class 4. If you are using in your mobile phone, you can use a very cheaper cheaper memory card. And the same, if you want to buy for recording some DSLR camera or something, it will go up to 5,000, 6,000 for even 1 GB, 2 GB, something like that. So there are multiple classes in the hardware itself. So that is the hardware is bit less, but it is not exactly our laptop hard disk. It is next level, but less than the production level. That is commodity hardware.
Then I feel the reason is it's highly replaceable in Hadoop system, whereas it cannot be done in Oracle or something else.
Highly replaceable. Okay, let's discuss that also. Highly replaceable. Let's discuss that also. Highly replaceable. And one more thing, I'll just give you one more perspective about commodity hardware. So 1 TB of high software, high aware, like 1 TB of production level hardware, high availability hardware, that cost around $1 million as per Teradata requirement. In past 2 years, 3 years back, they require 1 TB of high production level hardware for their system to run. It requires $1 million. And the same, we can get 1 TB of a hard disk in 5,000 rupees, which is $100. Correct? So that is the difference between the production level system and local hardware. But the same, commodity hardware comes in between. Commodity hardware comes in between. It costs around probably 10 times more than our laptop hardware. That's what I would say. 10,000 K maximum. That's what it will cost. But it is prone to failure. Okay. But it is prone to failures. That's what the main point is. Okay.
10,000K?
No, I just give for example. It is not sure. $10,000 per 1 TB. It's not exactly the figure. I'm just making up some idea how much it will be. 1 TB, $10,000 for 1 TB, probably. But it will be much lesser. Even $1 million, where is it? Like $10,000. There's a large gap, right? So that's what I'm trying to make a point. It will be that much difference will be there. Okay, so that's fine. Just move on. And it is highly replaceable. Yeah, that is correct. But even though it is highly replaceable, while the production system is running, we are running a Hadoop system, we are running a Spark system. In that case, if it fails, we cannot go and keep on replacing. That has to be some other way to handle it. So how we are handling? Yeah.
Hadoop itself will take care of it, right? So when it is so some node is not available, so automatically it will pass on to some other.
Yeah, exactly. It has to pass on. That is a mechanism Hadoop has implemented. For that, what they implemented is a replication factor. Replication factor. Replication factor they have implemented. So what happens is, even you have one file, 1 GB of one file we have. What we will do is we will make a 3 copy of it and then store it. Store it in a different places in a cluster, in different nodes itself. So that even if one node fails, we will take the copy from the another node. That's what yesterday Usman was discussing under replication. So if it is under replication, it is name node's jobs to make sure always the replication is met. Okay. So that's how we are handling. That's why Hadoop can use commodity hardware, whereas the other systems cannot use commodity hardware because they are prone to failure. If it is fails, then the data might crash and it will always go out. So that's why they will not be able to do it. Hadoop is using commodity hardware. That is the main reason. That's how they handle this. Designed to run on commodity hardware. How? Using replication factor. We'll just, if the one file is there, they'll copy it 3 times. So does that mean we'll be losing a lot of memory? Yes. But as you see the comparison of the memory cost, it is very cheaper. Even you have 1 TB of data, you put into Hadoop, it becomes 3 TB. Just to store it, it becomes 3 TB. Correct. But even though that is lesser than the cost whatever you are spending into the high-end systems, high-end hardware. That's the comparison. Okay, everybody got it? Till now everybody is clear?
So you mean to say that using the commodity hardware, the Hadoop is cheaper than any other RDBMS tools?
Exactly.
Okay.
One second. Is anyone from Oracle or Terra? I think Vinod is off today. The question is.
Yeah.
So we also in RDBMS also we will be taking the backup, right? So
correct. Exactly. So even though it will be also costly. The backup whatever you're taking, you will be taking how much interval it will be taken. The backup is different. This is even while running it. Once you store itself, it will be stored in 3 times. Even the same mechanism. Do you have in like Oracle or something in that production level systems?
okay.
If it goes, that will be even more costlier. Because the data is already cost over, the hardware is already costly, that it will be going over costlier. The cost will not be viable to business. The return on investment will not be there. So that is the reason. And also one more thing is there. What is that? The speed of data to be accessed. The Oracle and those things, that is not, it has some parallelism and some mechanism architecture, and that is not entirely parallel, and those needs to be read very faster. So that kind of hardware only they require. That is the reason they require this hardware. Here we have the distributed environment. So the speed also will be distributed. The map reduce will process on each node. So that is also being distributed. So that is also one more case.
So this Hadoop has an parallel or serial, like how does this?
Hadoop is a parallel, entirely parallel system, distributed system, and it's a parallel one. Okay. And it's highly fault tolerant, designed to be deployed on low cost hardware. That's what we just saw. Based on use the replication factor, we are handling it. And hardware failures, streaming access, large data set, write once and many to model. So here, hardware failures. Yeah, there will be a lot of hardware failures in Hadoop. That is very much possible, and that is expected because it is a commodity hardware. And the streaming access. So large data set and streaming access, both is we will have to deal with a single thing. For this only, we have the block size as a big, like we have block size as 64 MB, 64 MB as a minimum. in version 1. Now it is 512 MB, sorry, 128 MB minimum, and it's a default one. That much block size. Because we will be needing streaming access. Once we start reading the data, we have to read continuously. We have to do the analysis continuously. That is why we have streaming access and large data set. The data set we are expecting in Hadoop is large. It is not going to be some small files like 1 TB, 1 KB files. No, it will be in TBs and GBs files. It will be large. So that is what it is trying to solve. So that's why we have a block size as a larger one. And then it is write once, read many model. Okay, so for this I'll just write one thing. This is our Windows. Okay, this is a Windows system which you are currently running. Windows. Inside we have with the VMware help. This is VMware. I hope everybody installed VMware. Inside we have Linux. Okay, this is Linux. This is Linux. Inside we have HDFS. HDFS file system is installed. This is HDFS. Okay, so this is your Windows system. Inside with the help of VMware or VirtualBox, whatever you can use. VMware. With the help of VMware, we have Linux. Inside Linux, we installed HDFS. Fine. Everybody is clear with this architecture, whatever we are using. So here in HDFS, whatever data you put, you cannot edit a file in HDFS.
Right, and Shyama, Abhi.
Yeah, I will just mute. Okay, so we cannot edit any files in HDFS. It's like a write once, read many times model. Let's say you have 1 TB file and you just put into Hadoop. I'll just open my virtual machine for that. I'm just turning on my virtual machine. Okay, so I have two versions, 5.8 also is there, 4.4 is also there. For this, it's 10 GB it's required, so I'll just go with the lower version, 4.4. So I'm just opening it. Okay, so let it open. Meanwhile, we'll just discuss the points. HDFS is like write once, read many models. You cannot, once you put the file into HDFS, write once, once the file is placed into HDFS, it cannot be edited. Okay, once you put the file into HDFS, it cannot be edited. It can be transformed or created. We can create this using this file. We can process and create new file, but we cannot just edit the existing file. That's how the HDFS is designed. Once it open, I'll show you the demo what I'm telling. Okay, but once you put the data, you cannot edit the file. Here in Windows, we can edit the file. Like we are writing currently and saving it. Class notes 26/09/2018. March, Tamil moving big data September batch class notes. Okay. I'm just saving this file in that. Here we are editing it and storing it. Such facility is not there in HDFS. All right. Okay. So till now everybody is clear. This is our HDFS resides. And let's say you have one more system. You have one more laptop. Like you have one laptop, I'm having one laptop. I can do is here also I'll be having, and I will be also having the VMware and same. I will also have the HDFS. I will also have HDFS. So here it is 20 GB is there. Let's say here it is 20 GB. Here it is 20 GB. So totally virtually like underneath this will be like this. In production system everywhere this will be like this. Only difference is Windows will not be there in production system. Directly they will have the Linux, so we can use it. So this will be like that, and the entire HDFS like size will be 40 GB. If you configure it in this way, it will be entirely HDFS 40 GB. This is how the distributed system works. This is how the distributed system is designed. This is laptop 1, laptop 2. We call it as node 1, node 2. Node 1. I need to give a different color. Node 1, node 2. So we'll take a pass here. Yeah, Anbuji and Ganeshi and Shankarji, Shivaramji and Anandji. Is this diagram is making sense?
Yes. Yeah, good.
I have a question. See, we have Oracle Big Data and we have Apache Hadoop. So which one to go for that? If you say from the appliance perspective, Oracle is having high volume, or from the cost perspective?
Okay. For now, we'll just park the question. We'll come to that in a few minutes. We'll come back to the question. Okay. That is a correct question. We'll come back. So is this one is clear? How, it's just a virtualization. It's just an idea to give idea how HDFS file system is stored, why it is storing as a block. Everything is based on this only. If you can understand this, all the upcoming sessions, whatever cluster management, whatever is coming in a rack awareness, etc., everything you will be able to understand if you can understand this clearly. What is HDFS? This is the exact part. This is clear. Can you have confirmation? Can you just say yes or no in the chat box, or maybe you can unmute the mic and say if you have any doubts. Just this diagram only you can focus. It's very simple. Okay, good. Thanks, Ji. Thanks, Ganeshji.
Yes, from Shankar.
Anandji. Thanks, Vincentji also. Vincentji says reply. Yes, no. Okay, so I'll just save this. Okay, thanks, Shankarji. So I'm just saving this. Class notes. HDFS idea behind the HDFS. This is how HDFS is stored in everywhere. Okay, so you can keep on increase the nodes. Like if I want to do 20 more GB, I'll just add one more node. Like here, since we are using Windows and we are doing virtual machine, I'm using Windows. In production system, there will not be any Windows. There will be only Linux. Linux will be there. In Linux, they will be allocated 20 GB for HDFS, and it is configured in such way. So that will be accordingly, that block size will be done like 64 MB or something like that. Totally, if you access HDFS, you will be accessing this virtual space. But underneath, it will be like this. One will be in one node, one will be in one node. If you store a data, it will be distributed and stored. If you process, everything happens like this. Okay. So I just saved it. So, okay. So I hope this is clear, because based on this only we'll be like drawing a lot of diagrams and how this works, map reduce, how blocks is moving across. Those we'll see. We'll come back.
Aru, 1 second.
Yes.
Can you go back? Yeah. Here, which is the data node here? So are we talking about the data node is 20 GB, right?
No. You don't go to data node, name node. We didn't go there. Like both are data nodes only. I just mentioned data node and name node. We did not mention it. If you want to make it in that way, you can configure this as a name node, this as a data node. That is entirely depends on our hand. You can make this one as data node, one as name node.
If that is the case, then the size will be 20 GB, right?
Correct. If that is the case, then size will be 20 GB. Correct. You're right. Or you can say you can create one more data node. Sorry, name node.
This is the size of the HDFS.
That means the cluster.
Yeah.
I have one question.
Yeah.
So the name node is only to create the metadata.
Yeah.
Okay, this will also use the HDFS, but only to create the metadata, right?
Correct. Name node is a special node. It is used for you to store metadata and store the metadata in RAM, and it helps. That's what name node does.
So the metadata in RAM as well as in the HDFS.
Metadata is not stored in HDFS. It is stored in name nodes like hard disk. If you want to restart or something, it's stored in that hard disk. That is called FSCV.
Okay, so it won't be at all in the HDFS.
Yeah, that space will not be come into HDFS. Only data node will be come into HDFS part.
Okay.
So I have a question here. No,
Yes.
we yesterday we spoke about the name nodes and other data nodes, right?
Yeah, yeah, yeah.
And when a data node fails, the name node will handle it accordingly, right?
Correct.
It will manage that.
Correct.
But what if the name node fails?
Exactly. That's what it's a single point of failure. If name node fails in version 1.0, it is single point of failure. Name node fails, your cluster fails. In 2.0, they come up with the idea of high availability that we will be covering in some time. Today only we'll cover it. In 1.0, it is a single point of failure. Because if your name node fails, that's it. Your file system crashes. Single point of failure, your failure. In 2.0, we come up with the thing called high availability. This is not a high availability which we talked earlier. This is a different high availability. This is having multiple name nodes supporting, and then it will give the access and all. This we will see it in some time. Okay.
Okay.
But 1.0 it is a single point of failure. In 2.0, we have handled it in using high availability, that is HA.
And I have another question on the block size, right? You know, HDFS system block size is bigger than the OS block size.
Exactly.
So Linux block size, you know, the maximum is like about 32 KB, right?
Okay.
So when this sits on a Linux system, right?
The
underlying operating system supports only a smaller block size.
Correct.
And how HDFS is handling a bigger block size on top of it?
Yeah, that is actually a good question, which we also came through. What happens is the block size of HDFS is a virtual one. So it will this will be masked by HDFS. Once we install HDFS, this will be masked by HDFS. Still the underlying will be FIDO or whatever it is, but it will be masked in HDFS that will be stored in that file system. It will be masked by HDFS file system. If whatever is allocated to HDFS, that will be masked. That will be having your MB. That file, those files. That's how they handle it.
I didn't get you. What you are saying that once it is into the HDFS, the underlying Linux, the 32 KB block will not be, 32 MB block will not be in place. Everything will be controlled by HDFS.
Correct. Once you allocate the space to HDFS and format it in the HDFS, those block size will be changed to 64 MB. It will be no more available to Linux. It will be available only for HDFS only. Those whatever memory you allocated. That is why it is not fully. Only 20 GB is allocated in Linux. So Linux is still have the control of that. So the file system will be formatted for HDFS.
So the Hadoop would override the Linux file system.
Correct. Hadoop will override the Linux file system. It will be so that it will have the block size as its own.
So it's not a configurable, but it automatically does that. It's not configurable.
No. What is not configurable?
No, the HDFS is not configured to mask or to override the Linux file system.
Correct. Yeah, it is not that way. Yes.
So the size is configurable. Only thing the process will be done automatically.
Correct. And
Hadoop is not piggybacking on the Linux file system, right?
It is kind of having a relation with Linux, but in this case, I will just get back to you on this one. How that is being connected with Linux. So there it is just more in the file system. I'll just get back to you on this one. And one more thing is there are different distributions, and this too, like Cloudera and Hartanox, they are still using Linux. Without Linux, it cannot function. but there is a distribution called MapR, and they don't require Linux. They can directly have file system, and that is very different than this two. So I'll just get back to you on this one only, like how it is formatted. Okay, that question I'll come back.
Okay. Because the reason for my question is, if the underlying OS has a limitation, and if this is just a kind of a virtual thing and sitting on top of it, then you have to live with the underlying OS limitations, right?
Correct. Yeah, exactly. That is right. But one masking will happen. I'm not sure which place it will happen and how it will happen. I'll just check and then get back to you on this masking thing.
Okay.
But that is right only. It will have to mask, and then only it will have a 64 MB. It will not like change the Linux file system. It will, but whatever is allocated to HDFS, that those file system, those memory is not available for Linux. That is sure. But how the masking is happened, that I will get back.
Okay.
Okay, sure.
Thank you.
Yeah, sure. Just go down. Masking Linux. Okay. Okay. So Oracle versus Hadoop. So if I think somebody had a question on this one, right? So can we use Oracle when instead of Hadoop, right? I believe Anbuji asked or Ganeshji who asked this question.
See, that was my question. But
Yeah.
prior to that, when you say Hadoop, I am going back to the previous question where Shiva asked if HDFS overseed or mask the Linux file system, then if the HDFS goes out, then how do you make sure because sizing? Okay, no, I got it.
Okay.
Yep.
Hello.
Sorry, my question was if in case HDFS goes off, then how do we handle that?
Yeah, for that only we have master slave architecture and those things, right? So we still have a control over there using our name node and name node. That is a master one. Here, I'll just write a proper HDFS one. That is name node. These things are data nodes. Okay, that is name node. These things are this is the entire cluster. Okay, this is, I'll say this is the one Hadoop cluster, and this is name node. These things are data nodes. Okay, so this will be connected here. This is using LAMP. It is connected, and if the HDFS goes down, then we will not be able to connect it from our Linux. Okay, so before that, currently my VM is logged in. Okay, so I'll just do right click and I'll just try to access a HDFS. Here I'm connecting Linux. I just put ls and it connects me to Linux environment, which is my desktop environment. If I want to connect to HDFS, all I have to do is Hadoop fs -ls /user/cloudera. So if I want to do just to list the number of files in Linux file system, I can do just ls and it will list. If I want to connect to HDFS, I have to always use the prefix called Hadoop fs, and then I have to put a syntax whatever I want to connect. Now it will show me whatever is there in HDFS. If you see, this is different, this is different. This is what I have in HDFS.
Okay.
So that's how we'll know if the HDFS file is down. Always we have this prefix to connect to that file system. There is a different, altogether different file system. And if you see, read write permissions are same. It's like Linux only. And if you see, there's a owner, group owner, and where the file is there, everything. And if you 3 numbers, this is 3 means it is replicated 3 times. This file is replicated 3 times. So that is the replication factor is shown. So that's how we can access HDFS from your local Linux.
Okay.
Got it?
Yep.
Yeah. So this is name node and these things are data nodes. So yeah, and Oracle versus Hadoop, what is the question, Ji?
No, I think based on whatever you are saying, Oracle has a high-end, cost-effective, and Hadoop is comparatively low. So, and what factor or company will go or decide which one to go, whether to Oracle or Hadoop?
Okay, fine. So here, Hadoop is not a replaceable to Oracle. Hadoop is not entirely replaceable for Oracle or any other high-end systems, because Hadoop, we already saw, Hadoop is write once, read many model. It is not the answer to all the questions. It is not answer for OLTP. We cannot update in Hadoop itself as per the current trend. Now we can do it, but as per the trend, we cannot write. If you want to write a transaction into Hadoop, it is not possible, because it might not, you cannot update it or something like that. We cannot do it. Hadoop is only used for storing large amount of data and processing. That is what Hadoop is till now. That is what it is used for. But Oracle is used for updation, and it is used for code operation, and it is for many more things, right? So in that case, Hadoop will not replace Oracle, but only whatever the analytics part, those data, if it is large and it is not much used, and if you want to do analysis, that data we can move into Hadoop, and we can use that data. You can use Hadoop storage for analysis and backup and archival, not for replacing Oracle.
I think when I say Oracle, I am talking Oracle Big Data, not the Oracle RDBM as just a database.
Oracle Big Data means which one you are talking? Oracle has big data, or Oracle's big data offering you are talking, or anything?
I think probably is referring to Exadata.
Okay, Exadata, right? Fine. That is the Oracle's way of coming up with the handling large data, right?
Big data, yeah.
Yes.
Okay. I'm not sure how cost effective that is. So we can use exactly. We just don't have to go to Exadata. Many companies are not going to Exadata. They are directly coming to Hadoop itself. Like they are using Cloudera and those things. And if Exadata is cost very much like similar to this, then they might go, because I'm not sure about the cost wise of Exadata. So if it is a big data processing and big data offering, then yes, everything can be used in Hadoop.
Okay, I think I'm good. I don't want to deviate from the Hadoop, so let's go with that.
Okay, sure. And moving computation is cheaper to moving data to computation. So here what happens is, data is till now what we see is data is distributed as a blocks and stored into different nodes. Here on block, here on block, here on block, here on block, here on block. It's just a representation. It is not actual how it does. Okay. So if you want to process one thing, okay, let's say you wanted to add everything, or you wanted to remove nulls from the data and store it. Okay. So in that case, we write a program in Python or Java, Python or Java or Scala. We may write a program in we may write a code. Okay, my code goes like this: read a line and then remove null. Okay, that's it. That's all I'll write it. Remove null, store it in new file, save it as a new file. Okay, so I'll write just a small program, and this piece of code, I want to run this on top of the file which is having 1 TB of size. Instead of, if it is a normal systems, entire 1 TB of file has to come to the processing where the processing is happening. There the process will happen, and then the result will be stored into the new file. That's how it happens in a usual way. Correct. The data will be read from the disk, and then it will come to the point where the processing is happening, then it will be stored into the new file where the disk is there. This is what normally happens, right? This is clear.
Yes.
Okay, but in Hadoop, what happens is this entire code block will go. This entire code block will go into the place where go into the data node where the data is reside, and the each code will run on parallel way. This code will run on this data, this chunk of data set, that block, this block. Everywhere it will do in a parallel processing, and the result will be stored as a new block here itself. Or if necessary, it will be stored into the different, altogether a different file or block that will be coming into the parts. But here the code will be going to each data node, and then the processing will happen here, so that the data don't have to move. Entire data doesn't have to move across everywhere to get the processing done. That is where we call it as moving computation to data is cheaper than moving data to computation. That's what this is. So we'll just ship the code to every data node, and the processing will happen right there. And why it is benefit and how it is achieved? Because the blocks is distributed everywhere in the node itself. Where the data is there, the code will go there. And how the code will go there? There should be a question. How the code will get to know this is where the data is there? That's where the name node will help with the metadata, where the file is stored. Then this code will be shipped over there, and then the processing will happen in data node itself. It will not come into name node, or the data will not be brought up into name node for processing. It will be processed right there in data node itself. That is one more way. That's one more benefit of HDFS.
Okay.
Fine.
How the 1 second. How the results are combined here?
Okay. That is altogether a different one, which is called map reduce. That once we go there, we will get to know. That is what we have a thing called map reduce. Okay, that we'll see in map reduce class. This is just the overall idea why we come to the HDFS.
Yeah,
Okay.
before the results, how the data manipulation, how the calculation will be done, like how the process data will happen, like
Yeah.
duplicate data across all three nodes, because then how which system will tell you do from line 1 to 5, and you do line 6 to 7, and you do line from 7 to 10. How does who is going to tell that? Which system?
That is entirely taken care by map reduce part.
Because all the nodes have the same data. Like if you execute it again in all the places, it's going to take the same time to execution.
Correct. Exactly, that is right. But those part, the processing part, and how the data distributes, that will be taken care by the processing part, which is map reduce. They have a different daemons, and which is called job tracker and task tracker. That will be taking care of those things, how and exactly what and does and how it happens. That will be taken care by those things. That will come into the next class. It will have after 2 class we'll see, but just I'm giving you a heads up. That will be taken care by these two daemons.
Aru, I have a question here.
Yeah.
Can I go back to the paint?
Yeah.
Okay, you said the entire the read to the entire code will come to each node, correct?
Correct.
Suppose if I have 1,000 lines of coding.
Okay.
So that each 1,000 lines will go to each node, but that will obviously will extend my computation time or processing time, correct?
Yeah. Let's say you have 1,000-line code. How much size it will come? What do you think? How much size it can grow up to? It will be in KBs, right?
Yes.
So that it doesn't matter. KBs are even very less only. So even though if you write a lakhs of code, we have a lakhs of code. In a big project, it will come to lakhs of code. Even it will come into MB size only, maximum megabytes only. So that can be easily shipped.
Okay, I have a different question. Like, see, the codes are moved to the different nodes,
Correct.
Which is fine. But suppose I have the test file 1 in the node 1, which has a 1 MB or 2 MB size.
Okay.
Sorry, 1 GB. So our blocks are in 512 bytes, right? 512 MB. 512 MB.
Okay.
So will it be okay? The 1 GB file or even a 10 GB file, will it be? It is available in Node 1. But while processing, will it be processed in the Node 1 itself, or it will be processed in across the different nodes?
If,
How it will be?
yeah,
And you said like MapReducer will decide that, right?
yeah, MapReducer will not. Yeah. Okay, go ahead. Complete the question.
Okay, the question is, if file size is 10 GB, will it be processed by in the same node, or it will be spread across? The file is available in Node 1 only. In that scenario, will it be processed in the Node 1 alone, or it will be distributed to multiple nodes?
If the file is available in Node 1, the processing will also 100% happen in Node 1 only. It will not happen in any other node. If it is a small file, that is the only scenario, because we don't have to move the data. 512 MB, we don't have to move the data to Node 2 and then process.
No, the file size is 10 GB.
10 GB, but everything is available in Node 1 only.
Yes.
In that case also same. It will get processed in Node 1 only.
Suppose I have a Node 1 hard disk, which is sufficient enough, but the memory is less. Even in that case also, it will be processed in Node 1.
In that case also, it will happen in Node 1 only. But the scenario here is HDFS will not store 10 GB file in one node. That is just for you, like the question we answered. But HDFS will never store the data in only one node. It will distribute it.
Okay, got it. That's
so
why.
That is the way it works. Yeah, correct.
So,
but everything
ideally the process.
Yeah.
Ideally, wherever the data is there, the process will happen over there only.
Exactly, the process will happen over there only to reduce the transactions over network size.
Got it.
But at the end, let's take one more scenario. Let's say you have 10 TB file, and the file is spread across all the nodes, and you wanted to find the maximum of numbers. Okay, maximum of number out of 10 TB. In that case, even though if you do parallel processing, you have to finally come to the conclusion. In that case, you need to compare every file. You need to compare the 100 GB file to be processed, right?
Yes.
So here we can do parallel processing. Okay, up to the extent we can do, but after that, at the end, even you have to compare after that also, because you need finally one number, not 10 numbers. So in that case only MapReduce kicks in. First map will happen, and then the results of those first processing will be moved across to the nodes, and it will come to only a single node. That is called MapReduce.
I have one question here. While during the mapping process, the code is moved to the respective nodes, right?
Okay.
To operate on the data. So when that operation is happening, if the node fails, what happens?
That will be taken care by job tracker. Task tracker, job tracker is there, right? That will be taken care by those things.
So the job will be moved to another node?
The job will be rescheduled in another one, because the replication is there in another node. It will be rescheduled.
Okay.
Using the job tracker and task tracker. We didn't go there so far, so that's why we didn't cover it. But yeah, we will see it. Job tracker and task tracker will take care.
Okay, thank you.
Okay, fine. We just slightly moved into processing part, but fine. I hope everybody is clear till now. Any other questions? Shankarji and Anandji.
Yeah. Can you just summarize the last part, that moving computation?
Okay, fine. So the data is spread across the nodes. If we want to process the data, we can ship all the data to one place and process it. That is one way of doing. Another way of doing what Hadoop is doing is, it will ship the code to all the data nodes where the data are there. Then it will process there itself. That's why we get the parallel processing. That is what moving computation to data is cheaper than moving data to computation. Like we are moving the computation to data node itself. We are not moving the large amount of data in initial itself. We are just moving the data like code to where the data is there. There it will be shipped.
That computation will be done by the MapReducer.
Correct. Computation will be done by MapReduce. Okay, Anandji and Ganeshi and Shankarji and Boji and Vincentji. Vincentji, I guess you like lost connection, right? Are you clear with the details we discussed? And Shivaramji, is everybody clear till now?
Yeah, I'm fine. Thank you.
Okay, fine.
Yeah, I'm good.
Fine. So, as initially we saw, there are two problems totally. Okay, one is to store the data, another one is to process. Store the data, another one is to process the data. For storing, we have HDFS. For processing, we have MapReduce. MapReduce, currently we started to use Spark heavily on this one. So for processing, we have MapReduce and Spark. We'll see both. Currently, we are seeing storing the data, how the storing is happening, what happens when the node fails and those things. Once we move complete HDFS, and then we'll go into MapReduce and then Spark. Okay, just for an overall idea, I'm just telling you. That doesn't. Okay, fine. Let's get into HDFS again. So this we've seen HDFS architecture. This is the overall HDFS architecture, like name node, secondary name node, and heartbeat balancing. Those things are there. Okay, so let's go into whatever we seen yesterday. We'll just have some questions. This is name node. This is data node 1, data node 2, data node 3. This is connected. This is connected. This is connected. Name node. Data node. Okay. So what is the use of secondary name node? Anyone can tell?
To store the files, backup
Backup of the primary node.
of the primary node.
Secondary node. Backup of the primary node. Okay.
So master, basically name node, backup of the name node, and as well as
Secondary name node.
it saves the file, and as well as it make the floppy. I mean, it makes the images.
Image.
Okay. It stores the image, right? Okay.
Yeah.
Okay. So fine. That's correct only. I am just putting a file here, a.txt. I'm just putting this file into HDFS. What will happen behind hood? What will happen, and what all the files will get written, and where it will be stored? Where this metadata of a.txt will be stored?
Name node.
That will be in the name node.
Okay. Any other specific
Data nodes.
No. Name node is right. Where in the name node? Yesterday we mentioned there is one specific log file.
Yeah, edit.
Yeah.
Correct. Exactly.
Edit log.
It will be stored. Okay.
Edit log.
So in edit log, the metadata of this will be stored, and the data will be stored where?
Data
In
stored
any
in
of the name nodes. Sorry,
Data nodes.
data nodes.
Any of the data nodes. Okay. Fine.
Three times.
So
Triple times.
triple times. For our use case, I'm just assuming we have here 600 MB file, and our block size is 64 MB. Okay, so 600 divided by 64. That's what I need to do right now.
9 blocks.
Okay, 9 blocks, approximately 9 blocks, right? So first block is here, second block is here, third block is here. I have 3 nodes. The first block is here, second block is here, the third block is here, first, second, third. Okay, it's stored like this. And so this is it correct?
No, everywhere 9.
Everywhere?
Everywhere it should have a 9.
Oh, okay, right. Yeah, that's also right. Because so since only we have 3 nodes, it will be the blocks will be distributed, but also it has to be replicated. That's why it will be stored like this. Okay. Now I'm just changing the replication factor.
So here one question. the 9 blocks we stored in 3 different nodes, right? So which correspond to one file. So if the replication is happening, the 3 copies will be stored in the same 3 nodes, or it can be in different nodes also, right?
Sorry. Come again.
So the 9 blocks stored in the 3 nodes correspond to one single file.
Correct.
So when we go for replication, the remaining 18 blocks, that is a 9 plus one more 9, which has to be stored in the same nodes, or it can be in different nodes also, right? Node 4 or node 5 or node 6.
Exactly. You can have, it will be stored in different nodes also. That is exactly right. But since we mentioned here only a 3-node cluster, that's why we are saying it. But if it is a 10-node or multi-node cluster, it will be stored in a different node for sure, in order to maintain the availability, more availability.
Okay.
Because let's say if we have few more nodes, the replication will be stored in there only. It will not be stored here at all. That's a very good question and a correct question. I hope everybody else also get the question. The question is, if we have 9 nodes or 10 nodes, or in production, or we'll have 30 nodes, casually we'll have 30 nodes or 40 nodes. In that case, how it will be stored? In that case, what will happen is, the replication of this will be stored in a different node only. It will not be stored in the same node, because what if the node fails? We have to get the replication. That is the overall point of storing the replication. So we cannot store it in the same node itself. So that's why we'll store in a different node. Here we just mentioned 3 nodes. That's why we are telling all the 9 nodes will be stored in first, and the replication will be all 3 nodes. Everybody gets it?
Yes.
Okay. So, okay. So replication factor is 3 initially. I am now changing it to 1, because replication factor is a file level. You can give each file different replication factors. Let's say you have one file which is very important, you can make it to 10. If your file is very less important, you can take it at 1. So replication factor is file level. Okay. In cluster level, it is defaulted to 3, and that also you can change it using the configuration file. But if you want to change the replication file for a specific file, you can change it. Okay. So replication fix 3. Now change it to 1. Then what happens? Then like this, the data is stored. Only without replication, it is stored. Okay. Fine.
So then the information about the each blocks will be stored in the edit log.
Yeah, correct. Edit log will always store the information.
Okay. And the file image will be created.
FS image will be created. It is there in here. In hard disk of name node, it will be stored.
Every 1 hour it will be transferred to backup node.
Secondary name node, every 1 hour this edit log will go there, and old FS image will be there. That both will be merged in secondary name node. You got it right? Edit log will be
all the
old FS image is already there. Old FS is there, which is 1 hour back. 1 hour back. Correct. That is already here.
Correct.
And new edit log has come.
Our own
And
question.
it will be merged here, and it will create new. Which both will be merged.
So, here one question.
Yeah.
The first time the FS image will be created in the name node 1 or the secondary node?
Name node 1.
Second.
First time.
Okay.
New FS image, and new FS image will be transferred to name node. This is the process. Secondary name node is used for only this purpose. It is used to merge the edit log and old FS image. Okay. Secondary node is used for this one. And what if the name node fails? This is a single point of failure. Can the secondary name node actually take up and do the processing? No. 1.0, that is not at all possible. Okay. So, okay, let's just put some data here and then we'll change it. Hadoop FS ls. Okay. I have, let's take the file FBI crime.java, that's a Java file, and the snowfall.csv file. I just will put the data into Hadoop. I'll use /user/Cloudera. So if I want to if I want to push the data from our Linux to HDFS, I will use put command. There is one more command, copy from local is also there, but I use put command to copy the data into HDFS. Hadoop FS. I'm just checking whether the data is there or not. Cloudera. So okay, so it is showing snowfall.csv is moved, and it is replication factor is 3, and it is size and what time I moved or what has happened. Is that clear? I just take one file from our Linux and then I moved into HDFS, and then I just showed. Now in the behind hoods, this process has happened. Name node show tell them where to store the block and how it's stored and all, and it is stored there. And set rep, I forget, set rep 4, right? 1. Okay, so previously the replication factor was 3 for this file. I just want to change it to different one. So what I did is I just used the setrep command and then I changed it. Usually we don't do it, but just I'm telling you, if in case now it is changed. Only this file is changed.
Yeah, Arun, one question.
Yeah.
In RDBMS, right? So we can go and see the data on the table, right?
Okay.
So is there any facility or any functionality is there in Hadoop to go and check it up the data or the files?
File, you want to see the content of the file?
Yeah.
And that you can do using cat. That is fine. This is just a Linux command only, so it shows the data. And where it stores background information also you can check. Like I'm saying you, it is stored in blocks 1, blocks 2. How to check the blocks, where the block is actually, that is also we can check. I'll tell you the comments tomorrow, but you can see the data. Yeah.
Okay. Okay. This is the normal file, right? So if it is here like audio file or some kind of video files.
Audio or video files you cannot play in HDFS. You will not be able to play it, right? You can see it using you have to use particular code C, codecs or those things for that.
In
unreadable format.
Yeah, in RDBMS, like we don't store, we can't store first of all. So here we are storing. So can we see that? Can we view that?
You cannot view it. If you see it using this way, it will not work. You have to use some Java program or Scala program to intercept, and then you have to use it. That way only you can do.
Okay.
Directly you cannot see, but you have to write a program or you have to use some utility for that.
So only this text or XML or CSV only can able to see, right?
Correct. Yeah. This is just like a text viewing notepad. It's like notepad only. It's a gedit. So you can see only those files. If you want to, even you cannot see the zip file or gunzip or those things. That you have to extract and then see, right? Same way goes for audio video files.
Okay. Thanks.
Yeah.
And Aru, I have a question.
Yeah, Ganesh.
So earlier you have 3 replication and you change it to 1 replication, correct?
Correct.
In that case, does HDFS redesign and remove the replication from other node, or what will happen to that?
Correct. It will be remove the replication. It will not have the whatever yesterday we discussed under replication. Now it will be over replicated. So once the space is needed, the name node will remove the other 2 copies, so that only 1 copy is stored.
And then the resizing will happen, and metadata will be updated. All these things happen in the backend, correct?
Everything will happen in name node itself. Okay.
Okay.
Yeah. So this is just a demo only. You have the files, whatever we are doing. It is there in the material. No, sir, not material. Assignments. We have HDFS. HDFS commands is there. Okay. You can just try running these commands, It's very simple. You don't have to follow the exact same thing. Whatever we do, you can also do. Initially, you will not have any data over there. It's just a blank. So you have to put data and then work on it. Assignment is there. And okay. So these are name node, data node, blocks. File can be larger than a single file. So what is the benefit of the HDFS? HDFS mainly, a file can be larger than a single system. Let's say, let's take more nodes. Let's say each node is 10 GB. Each data node is 10 GB we have for HDFS, we have 10 GB each node. Totally, it comes around 50 GB. 50 GB of size. So, I can store up to 50 GB of file in this, provided replication factor is 1. I can store a 50 GB single file, which is larger than a single system. Single system is only 10 GB. Only single system is 10 GB only, but I can store up to 50 GB of file, which is larger than any single system. Okay. So that is one more advantage of HDFS. And then secondary name node. What is secondary name node? That we just
Sorry.
sorry.
Yeah. Sorry. Could you please come again for this?
Okay. So you can store 50 GB of file in our Hadoop system, which whereas one single node is only 10 GB.
Okay.
Altogether, our HDFS file virtually, the HDFS file is a virtual file system. If you see, virtually you can see it as a 50 GB, but underline it is distributed among the nodes. Correct. So that is a benefit. That's what we see.
Okay. That means that the file can be more than the size of
single.
Okay, one data node.
Exactly, one data node. And then secondary name node you've seen. And what is heartbeat and block report? Any idea? Yesterday we saw.
So heartbeat in the sense we will use for kind of alarm, like a health checkup of the system.
Okay, right.
So in our terms.
Yeah, correct. So
this kind of a proactive alert system.
Correct. So we keep on writing these lines like this is connected, this is connected, this is connected. How does it connected actually? So it is connected through LAN. Yeah, that is fine. How? Let's say this the data node is, this is name node. Okay, I'll just write this name node. Let's say this data node is failed. Okay, this data node is failed. How does name node knows the data node is failed?
Don't get any response for a certain time.
Sorry?
You don't get any response from the data node for a certain time.
So correct.
That's where the heartbeat comes.
Yeah, exactly. That's where the heartbeat comes. Each 10 seconds, the data node will be sending a heartbeat. So what is heartbeat? It is nothing but just one single, KB, 1 KB. It's not even KB. It is 1 byte file or something like that. Some signal to note that the system is available in that particular network. If the data node does not get heartbeat from a particular data node, then it will assume that the node is failed. Then it will replicate whatever the data is there. It will start replicating those into other nodes to maintain the replication factor and other things. So that is called heartbeat.
Here I have one question. So the moment the node is lost, so it will replicate the data from there, right? So that's what you're saying. Correct. So when the node is lost, how it can be replicated? So it probably from the copy of other node?
Yeah, exactly. From the copy of other node. It is just one copy is lost, other copy is there in other places. So that will be copied and that will be distributed. And name node will know only by heartbeat the data node is not alive or not. Only that signal is used for that one. And one more, that is a signal to note the data node is alive or not. And one more, the information will be passed from data node to name node. That is called block report. Block report. So block report means each node will send, this is also periodically interval will be 1 minute, that is also configurable. Block report will contain how many blocks I have in my node and what are the, how many blocks are actually intact, what are the blocks are unused and what is those things. Those report also will be sent from data node to name node. That is called block report. Two things data node will send to name node to data node. That is, one is heartbeat. Another one is block report.
Like from data node to name node.
Yeah, both are data node to name node. There is no communication from name node to data node. Always communication is data node to name node only. Data node to.
So the computation results will not send it to data node.
Computation, we don't have to go to computation yet. We didn't go so far. That will be taken in a different way. Okay. That is handled for different daemons, and that is for, because computation is just once the data is processing. This is how data is processed, how data is maintained, how data is intact, how the HDFS works. That is that's what we are saying. We don't go into processing yet, because processing will have, processing is what? You just read the data and process it. Whatever is near, you just go and take it. That will be different scenario. Yeah. This is what we are saying is, once the data is stored, we have to ensure the system is up and running and it is not down or something like that. Okay. That is heartbeat and block report, and then FS image and edit log that we just saw. That is a secondary name node. It is, we can use it, and we have it in class notes, block report, here, right? Yeah, we have it here, secondary name node. Yeah.
Since you talk about the heartbeat and block report, we use something called checksum actually.
Yeah.
Is there anything that we have it in HDFS?
Yeah, there is a checksum process, but that is not used here. Like checksum is just whether the data is actually correctly transferred from here and there and back to the fourth, right?
Correct.
Yeah, that is a basic mechanism that is here also. Whether the data is being correctly transmitted or not, that is checksum will be added. That is part of data transfer. That is there. And few things we need to see: HDFS high availability and failover and fencing, and safe mode and rack awareness. Okay, so what is safe mode? Safe mode is just the concept. What is safe mode means? We have everything we have stored in UFS image. Sometimes if you want to go for the restart, or sometimes if your many file system is failed, like there are almost 50 nodes are failed, in that case the system will go into safe mode. You can manually also bring the node into safe mode. In that case, what happens is you cannot write anything into the into your node. Why?
Yeah, I think Usman yesterday mentioned about safe mode, where when we have only one name node, at that time we will have a safe mode, and it goes for.
Yeah, correct. I saw. He mentioned. Yeah, that is one scenario, but many scenarios possible. While system is in safe mode, you cannot write the data, only you can read is possible. Okay, so that is
but that concept won't be there for name node and secondary node, correct?
Yeah, that's what he mentioned.
Name node and
secondary node. That's the between the name node and the data is transferring from name node to the edit logs are transferring. That time only.
We will have the safe node. But when we bring that name node and secondary node concept, I think I'm not sure whether the safe node is still goes into that or not.
Okay, safe mode is a concept that will happen in many reasons. All the reasons Usman said, that time also it will happen. if
No,
it is moving and all.
no. The question is, safe node concept wise we got it, but whether it is applicable to only name node and we don't have any secondary node, or if we have both name node and secondary node, during that time whether the safe mode comes into picture or not.
No, safe mode can come into picture at any time. It is not just you have high availability, then you will not be having a safe mode. It is in times. You can like say why? Because the safe mode will come into later. If entire system is down, if 50% of your system is down, that time you will go into safe mode. System is down. Then in order to recover, you will go into safe mode. That is one point. Another one, when you are restarting your cluster, it has to check whether all the blocks are intact and everything is there, as Usman also mentioned this yesterday. And all the blocks are intact and everything, it has to, name node has to check before allowing anyone to write the data. Okay, that will take around 30 minutes max. Like it depends on your size, block, cluster size. That time also system will be there in a safe mode. So if you are restarting name node, then it has to check everything. It has to bring everything into RAM, and then it has to check all the blocks are there, all the files are there in the same place, something like that. That is also, that time also system will be there in safe mode. And also one more scenario, administrator can bring the system into safe mode. That is something called force safe mode, then it will go into safe mode. That time also it can, admin can enforce them into safe mode for maintenance. Got it? Yeah, Shankarji, Anbuji, Ganeshji, and Shivramji and Shankarji.
Yeah, we are good. We are good. Only will the safe mode applicable to no data node also?
Yeah, exactly. Safe mode is applicable to entire cluster. You cannot write any data.
Okay, got it.
Okay, fine. So, any other questions till now? Whatever we saw, I'll just summarize what we saw from the beginning. So, the Hadoop distributed file system, it runs on commodity hardware. So, we don't have to go for expensive hardware, and it runs on commodity hardware because the failure is more. We use a replication factor to handle this scenario, and then it's highly fault tolerance and designed to be deployed on low hardware. How? Using the same replication factor. And hardware failure, streaming access, and large data set. Large data set and streaming access. For that, we have block sizes large. The minimum is 128 KB, and maximum block size we can have is 512. Sorry, minimum is 128 MB. Maximum files block size we can have is 512 MB. And then HDFS is a write once, read many model. Once we put the data into HDFS, we cannot edit the file, but we can transform the file into new file. That is possible. And then moving the computation to data is cheaper than moving the data to computation. What this means is we'll just move the code to each data nodes so that it can process the data blocks, whatever is there in the data node itself. That is the point. And then we saw about name node, secondary name node, and the heartbeats, and then replication we saw, and then safe mode, first image, edit log, heartbeat, block report, secondary name node, data node, name node. Okay, that's what we saw. Tomorrow we'll see the high availability, HCA, and then failover and fencing, how it happens, and what is rack awareness. And then we'll see HDFS, one more architecture, how write is happening, read is happening. And then we'll see some hands-on from tomorrow. Today also we just saw how to push data and all. Tomorrow also we'll see those things. Okay. So any other doubts? If you have any doubts, you can stay on the class or.
What is that balancing? Like I saw that on that screen, balancing.
Yeah. Balancing is, it's nothing. It's like if data is loaded into one node, it will be go into another node. It sort of balances everything. That we will see tomorrow in high availability class. Like if everything is as initially, I think Ganeshji asked the question, I guess. Like everything is stored, if 10 GB is stored into one node, in that case only you have only one node. Suddenly what happens is after one day, you add one more node to the cluster. In that case, balancing happens by name node. It will push half of the blocks into new node. That's called balancing.
Okay.
That is balancing. Heartbeats, replication, balancing. So, any other doubts?
I'm good.
Anandji, Shankarji, Anpuji, and Ganeshji, Shivaramji, and Sankarji. Today we just went 10 minutes ahead. And
I'm
tomorrow
okay.
we'll
Good.
start sharp by 6:30. Yeah.
Thanks.
Okay, I hope today's class is useful and interesting. And thank you. Thanks for attending today's class. Tomorrow we'll meet in the same class and we'll meet sharp at 6:30 IST. Thank you. Thanks, everyone.
Thank you.
Yeah.
Have a good day. Bye.
Yeah, bye.